Hello, Math 30-1. Welcome to a new unit on polynomial functions. So in this unit, we obviously are taking a new function, a polynomial function, and we're going to need some skills along the way. We're going to need to use long division and synthetic, and we'll need to divide using that. We've talked about zeros before, or x-intercepts of quadratics, but we're really going to look at the equations of polynomials and how we can determine their graph without going through the graphing calculator and allowing technology. So the first thing we want to make sure is define what these things are. So what is it? Well, clearly there's the equation, but what does that mean, right? Well, the values you see, a and a1, a2, a3, those are just coefficients, numerical coefficients. But the coefficient of the highest degree term is called the leading coefficient, because we put them in descending order. The term independent of x, that's this little guy at the back, he's the guy without an x, and he's called the constant term. The highest degree exponent is called the degree of the polynomial, and those things really matter, right? So example 1, state the following, the degree of the leading coefficient of each of those. So complete it and come back to see whether you understood those terms. Okay, so when you look, okay, so the degree of it was 4, the leading coefficient was 1, and the constant was 5. Please ask if those didn't make sense tomorrow. Expressions containing roots of variables, negative fractional powers, or any coefficient which is non-real is not a polynomial function. Those are other special kinds of functions, but they're not polynomial. Okay? So let's look and see, well, which ones of these are or are not polynomials, and see whether the definition makes sense. The words are there, but do they make sense? Okay, so you decide and then come back and look at the screencast. Don't just copy it down. Okay, first one, it is not, because it has a rational exponent in the power. Can't have that. Number 2 is not. Why? Because it has a negative power in the top, and that makes it 1 over x. So that doesn't make it a polynomial. Okay, you can't have that. It's a rational function. In C, well, you look at it, we got some weird coefficients there, but that's not what makes it a not polynomial. We all have 4 and 3 and 2 and 1 for exponents, so we don't need to worry about that one not. It is. In the third one, it is not, because the first term, as you can see, in D, the first term, as you can see, has x to the exponent 3/2. That's a problem. You can't have a rational exponent. In E, again, we have the same issue. In E, you can't have it is a rational, but in the end, the square root of x squared is just x to the 1. So that is a rational exponent. Everything is a-okay. We don't have to worry about it. And lastly, we have a coefficient which is non-real. We have an imaginary number as a coefficient. That is not a rational function. Okay? Hopefully that clears the waters. And then the next thing we are considering by classifying, sometimes it's in disguised form. So we want to state the degree of the leading coefficient and constant term of each. All right? So again, make the words make sense. I want you to try and then come back to see whether it makes sense. So in the first one, the degree is 3. That's the highest degree. It's put in a weird order. Its leading coefficient is minus 25, and its constant is minus 39. In the second one, it's in factored form, so its degree is 2 when you multiply it out. Its leading coefficient is, I put 10 there, yeah, because I screwed this up. Boink. That should have been a 10x squared, and we end up with minus 7 as the constant term, okay? So we're going to be working a lot. So we're building skills. Can you find out those characteristics of a polynomial without doing this work? And as you can see here, I don't want to expand it and simplify. It's no fun, too much work. Okay, so can you look and see what each of those are without expanding these all out? They are disguised, you might say. Okay, so can you expand that out and see? So in the first one, I can see that I'm going to have an x squared and an x squared. It's going to make x to the 4th. when I look at the leading coefficient, I got a 2, a 9, and a 2, a 9, and a 5. That makes 90. For the constant, I've got a 2, a 1, and a 1. That makes 2. If that doesn't make sense, again, we'll chat. And then B, obviously, my highest degree I'm going to have with this is squared, so its degree is 2. The leading coefficient is a 23x squared. That's how many I'll have. I'm going to have 18x squared plus 5 is 23, and my constant term is going to be 3. But don't trust me. Ask about that next day if that didn't make sense. The next example is just about review, so please read the terms, make sure those make sense. But number of terms, trinomial, binomial, so on, and degree. Classify this next example according to that. So you have a look and see. If we look at number 1, that's a constant term. 2, it is a degree 1 and it's linear. Degree 2 and it's quadratic. Degree 3 and it's cubic. Degree 4 and it's quartic. And we have many other ones, quintic and hexic and heptic and octic and so on, okay? What about the type of coefficients? We have integral polynomials and we have rational polynomials. We have real polynomial functions as well, so lots of note. So can you put the words into actual equations? Do you know what they mean? When you look at this, can you write one that's trinomial, quartic, and integral? Well, there's an example, but there's an infinite number of more, right? So this isn't supposed to be you copying my example down. You write a different one down. Can you write one that's binomial, linear, and real? Oh, I got a good one. Pi x minus 1, or even 3x minus 1. It is real. It doesn't have to be crazy. And then it's monomial. It's quadratic and it's rational. So technically 2x squared is rational too, but I mean, you might want to have p at x is equal to 3 over 19x squared. So there could be lots of different things it could be. Now, finally, we get something where we've done with definitions. Now, what kind of question might I ask? I probably wouldn't ask any of those other ones, but what if we were told that p at x was equal to this and you need to find the value of a? Use the concept of substitution to plug in my y value is minus 9, my x value is my x value is 1, I plug it in and I end up with minus 9 equals 5 plus a, so a equals minus 14. Maybe math 20, math 10, but now we get to finally a math 30 question. Good question for an exam. I was given a quadratic. It had a point of 2 and minus 18 and a point of minus 3 and minus 13. Find out what a and b are. All right? Well, we end up with 2 pieces of information, and that gives me 2 equations. Plug in 2, and you get 2 nice equations. One of them is 2a plus b equals minus 10, and the other one is minus 3a plus b equals 5. I'm sure math 10 comes to mind in solving systems of equations, and we can either use elimination or we can use substitution, and either way we find out that a is equal to minus 3 and b is equal to minus 4. Good job, and we'll see you next day, but this is more like what we're at. The rest was just definitions.